Google and Amazon both ask this one all the time. It's LeetCode 169, majority element. You're given an array of numbers. Your job is to find the majority element, the one that appears more than half the time. If the array has 7 elements, the majority element shows up at least 4 times. If it has 8 elements, at least 5 times. So if you have 3, 2, 3, the answer is 3. It appears twice out of 3 elements, which is more than half. The problem guarantees a majority element always exists. The obvious approach is to count occurrences with a hash map. Loop through, count each number, return the one with the highest count. That works, but it uses O of n extra space. Can we do better? Here's a clever idea called the Boyer-Moore voting algorithm. Think of it like an election. Each number is a candidate. Numbers that match the current candidate are votes for it. Numbers that differ are votes against it. The key insight is this. If one candidate has more than half the votes, they can't be eliminated. Even if every other candidate teams up against them, the majority candidate still has more supporters. Here's the strategy. Keep track of a candidate and a count. When the count hits 0, pick the current number as the new candidate. If the current number matches the candidate, increment. If it differs, decrement. The majority element will survive this process. Let me walk through an example. Take the array 2, 2, 1, 1, 1, 2, 2. Start with count 0. We see 2. Count is 0, so 2 becomes our candidate. Set count to 1. Next is 2. It matches our candidate. Count goes to 2. Next is 1. 1 differs from 2. Decrement count to 1. Next is 1 again. Still differs from 2. Decrement count to 0. Now we see 1. Count is 0, so 1 becomes our new candidate. Set count to 1. Next is 2. 2 differs from 1. Decrement count to 0. Finally, we see 2. Count is 0, so 2 becomes our candidate. Count is 1. We're done. Our candidate is 2. Let's verify. 2 appears 4 times in our array of 7. 4 is greater than 3.5, so 2 is indeed the majority. Why did this work? When we see different elements, they cancel each other out. But the majority element appears more than half the time. Even after all possible cancellations, it still has leftover occurrences. That's why it survives to the end. Time complexity is O of n. We scan the array once. Space complexity is O of 1. We only store 2 variables, the candidate and the count. Found this useful? Master key interview patterns at AlgoMonster and land your dream job.